All right, lesson 19 is on the mathematics of finance. So we have done some basic problems with finance before. Okay, so we're going to start out with a quick review of the basic functions. Okay, so it says Allie invests money into two accounts. One is continuously compounded at 2.6% annual interest, and the other is compounded monthly at 2.7% annual interest. If she invests $500 into both of these accounts, so each account, how much will she have total after 1 year? Okay, so after 1 year, we need to talk about the continuously compounded, and we need to talk about the monthly, and then we're going to add them together. All right, so continuously compounded, whenever we see continuously, we do A of t equals PE to the RT. And this really doesn't happen much with money. Okay, we don't do a lot of things continuously compounded. Usually it's like bacteria or exponential decay or something like that. So our initial amount is $500, and she's investing it at a 2.6% interest rate. So I'm going to do 0.026, and I want to find at the end of 1 year, so times 1. So that's A of 1, the amount after 1 year. So when I find this, it's not drastically different than the $500 originally. I end up getting $513.17. Okay, I round to cents, obviously, since money. All right, now monthly. That's the one that uses the P times 1 plus R over N raised to the NT. So I have $500. I'll write the formula out. And I'm investing at a 2.7% compounded monthly for 1 year. So for this one, we get a very similar amount. We get $513.67, so slightly more. So if I want to find the total, I just add those together. Okay, so her total is $1,026.84. Okay, so we did a quick review of continuously and monthly and so on. Yeah, Caroline.
Is it like just ironic that they're the same?
Yeah, they're very, very close. Yeah, because the annual interest rates are close. Yeah, so compounded continuously. It's not saying that at every single millisecond you're adding 2.6% in. It's just saying kind of over the general year, that's around what your percentage rate is. So, and just like the other one, it's saying for an annual interest rate, it's close. All right, so it's confusing sometimes when you're comparing investments. Maybe you're going to the bank and one of them has compounded monthly and one of them has compounded daily, and they're different percentage rates, and you're like, what's going to be better for me at the end of the year? Okay, so what we use, and banks will have this, is something called APY, so annual percentage yield. Okay, that is a number that you want to look at to compare different accounts, okay? So it says sometimes it's useful to compare two different options of investment. Above, we have two different accounts, and one yielded a little bit more than the other, but not much. So in order to compare several different options, we use something called annual percentage yield. This is the percentage rate that would yield the same outcome if it was only compounded at the end of each year. So we're saying, okay, forget that it's compounded monthly, or forget that it's compounded continuously. Let's just find how much I gained, what percent I gained at the end of the year. Okay, that's all it's saying. So let me kind of explain this problem. So it says Mrs. Cox invests $5,000 into Chase Bank at 4.17% annual interest compounded monthly. Okay, that's not actually what I'm getting at the end of every single month, right? This is just kind of an annual interest around there with the compounded monthly. So if I was finding this problem, we know that we would set it up as the 5,000, and we'd have 1 plus our rate, 0.0417, divided by 12, that's a 7 there, raised to the 12, and I'm finding at the end of a year. Okay, I want to find what's called the equivalent APY. Whenever you're finding the APY, it's saying, well, what if you had that amount of money and you just invested it at any rate for a single year? So it's compounded at the end of the year. So see how N is 1? So it's kind of like R over 1, 1 times 1 there. That's what we're doing. Now, if you notice, it doesn't matter how much money I'm investing, because if I divide by 5,000, it's totally gone. So in the problem, we actually don't even need a 5,000. It's out. What we're doing is we're just comparing the part that was in parentheses raised to a power. Okay, that's what we're comparing. We're finding what annual rate gives the same thing as this 4.17% compounded monthly. So we're solving this equation. So on the left-hand side, I'm going to do the 0.0417 divided by 12, and I'm going to add 1 to it, and I'm going to raise it to the 12. And when I do that, I get 1.042506296. I'll give all those decimals so you can see them. Did you guys get that when you did it along with me? You're all putting this in? Equals 1 plus r. So when I subtract 1, I get r equals 0.042506, and so on. So what is that equivalent to? It's around 4.25%, right? It should always be pretty darn close to the percent that you were given. We were given 4.17%. It worked out that it was actually a little bit better. At the end of the year, it was equivalent to getting 4.25% at the end of the year. Does that make sense? That's what annual percentage yield is. So to set up these problems, you always have like 1 plus r equals, and then that equation that you had, except you don't have a p. Okay, and then the time is 1 for each of them. Okay, so it says, which investment is better? One that pays 3.75% compounded quarterly, or one that pays 3.7 compounded monthly? So we're going to find the APYs for both of those in order to compare them. Okay, so I'm going to find the APY for 3.75% quarterly. So it doesn't matter what amount of money I start with, and that's why I didn't even give it to you. We don't put the P in the problem, okay? So we do 1 plus 0.0375. It's quarterly, so divided by 4. Raised to the 4 times 1. T is always 1 for these problems. All right, equals 1 plus r raised to the 1. See how you just write 1 plus r. So we find them. So we do our 0.0375 divided by 4 plus 1, and we raise it to the 4. So I get 1.038030647 equals 1 plus r. So that means my annual percentage rate, 0.03803, is around 3.803%. I always write down a lot of decimals for these because sometimes they're super, super close, and you need to go to like the 4th or 5th decimal. All right, so compounded monthly. So APY for 3.7% monthly. So let's see which one's better. So we're going to set it up the same way. So it's going to be 1 plus 0.037 divided by 12 to the 12 times 1 equals 1 plus r, the 1. So I end up getting r equals 0.0376339, let's say 334, or 34, I guess. So what's that? It's around 3.763%. So what's better? The first one, right? So this is what's better. So do you see what we're doing? So we're comparing the annual yield at the end of the year. So what percent did I gain at the end of the year? Okay. So in Algebra 2, we talked about investments, but we didn't really talk about realistic investments. I gave you guys problems like Cameron invested $5,000 into an account and then waited 20 years before he did anything to the account. How much did he have at this interest rate and so on? And is that how we invest money? No, not at all. Like Algebra 2 is so unrealistic, okay? What we typically do, girls, when we invest money is we invest the same amount every single pay period. So all of you someday are going to have retirement accounts. And I know it seems weird that I'm going to talk to you about your retirement account right now, but it's super important. As soon as you sign up for a job, you have to start investing money in your retirement account. Okay, so what you will typically do is you'll take money out of your paycheck. A lot of times it's pre-tax, meaning, you know, let's say you make, I don't know, let's say you're making a ton of money. You're making $5,000 a month. Woo, $5,000 a month, not a ton. And you end up, you know, every single paycheck, let's say you get $2,500 every 2 weeks. So out of each paycheck, you're taking out $500 to put in your retirement account. Okay, does that make sense? Sometimes, so then you're taxing after that. So then you're taxing, and so that's not part of the taxes that you're paying. So that's good to invest before taxes. Okay, so lots of times you do that. But sometimes your company matches. So University High School actually does that. So, I take out a lot of money to my retirement account because I'm young and I'm investing more like rapidly. I'm being riskier with my investments because I'm young, or so I think I am. And I'm taking out a lot of money, and the school is matching it up to a certain point. So if they match, let's say $500, how much do I want to take out? I want to take out $500, so the school puts in $500 too. Does that make sense? So it kind of depends on how much you're taking out. So this is how investments work. So this is how like 401ks or 403bs, these are how retirement accounts work, okay? You're often taking something out of your paycheck and you're putting it in every single period, okay? So let's say, suppose someone wants to deposit the same amount of money every month, every year, etc. So in my case, it's every 2 weeks, but we'll say every month. This is called an annuity. So an annuity is just basically a sequence of periodic payments that's leading to a big investment at the end, some kind of big retirement account or whatever. So for example, maybe Mrs. Cox is putting in $200 into her 4% interest retirement account every month, and she wants to know how much she will have after she's worked 4 years. That's not very much money, so we'll see. The way that you would do this is at the end of the first month, right, we just have $200. I put in $200. But what happens for the second month is I'm now putting in another $200, but my $200 from the first month has now grown, right? It's growing by 4% every single month. So I have 200 times 1.04. What is 200 times 1.04? $208. I had the $200 I had before, and I gained a 4%. I gained $8. Does that make sense? So now at the end of this month, I have $408. So what's going to happen on the next month? The $408 is now going to grow by 4%. So multiplied by 1.04. But I'm putting in another $200. Do you see how it works? So this is a very realistic example of what happens with retirement accounts and so on. We are putting money in every single time. We don't just put in $10,000 and then just wait for 50 years and hope, oh, I hope that's enough to retire on. That's not how things work. You invest constantly. Okay? So this is called an annuity. And the formula for an annuity is very weird. I will give you this formula. I'm also going to give you 2 other formulas that kind of go with it. So it says future value of an annuity. The future value, F of V, of an annuity consisting of n equal periodic payments of R dollars at an interest rate of I per compounding period is this. Now previously we used R for our interest rate. Now we're using I. That's because I is different. What I is your usual rate divided by the number of times it's compounded. So it's R over N, which is, common. We had that in our last formula too. All right, but what N is, capital N, it's not little n. It's N times T. It's the total number of times that you're compounding over those 40 years or whatever. So if you're compounding monthly over 40 years, it would be 480. Does that make sense?
So I is not
I is not your interest rate. I is, oh, are you saying it's not like the square root of -1? No, it's not. Were you like, how did that work out? Yeah, it's very confusing. So when I give you guys these formulas, I'll give you all 3 of these because they all go together, okay? All right, so at the end of each quarter, we'll put $700 into his 403b. Do you guys know how much you need to retire, by the way? You need a lot of money. Do you know why you need a lot of money? You need like $1 million when you retire. Do you know why that is? What age do you usually retire? 65. Yeah, 60, 65, somewhere around there. How long do people usually live? Not to 66, that would be the saddest thing ever. They usually live a little bit longer, right? So some people are living until they're 95 years old, right? That means that they need all of that money that they retired on to last them as long as they live, right? It's very, very sad. I have a lot of, my husband's grandparents are to the point where they've run out of their money, right? So it's a sad situation. You need a ton of money when you retire. You need to have an account that has like $1 million in it, right? What do you do when you run out? I don't know. You live on Social Security, or not Social Security, you live off the government. You have your family pay. I mean, we pay money to help them out. I mean, I think that's what you have to do, right? So how do you do it? Okay, so you need to be wise investors. All right, so at the end of the quarter, we'll put $700 into his 403b, which is like a 401k. Okay, the younger you are, the more aggressive your plan is, meaning you're putting things in things like stocks. Stocks can give you a huge return on your investment. Okay, this makes sense? So you want to invest things in things like stocks, okay? But if you're doing a more conservative plan, you're usually older. So Maury and I talk about this a lot. We have different retirement accounts. Maury has a very conservative plan. He has made his money over the last year, last however many years. And now he is just kind of riding it out until retirement. Why? He's closer to retirement, right? He doesn't want to invest in something that's super risky and lose half of his savings in the last 5 years before his retirement. Does that make sense? You don't want to risk. So you have different percentage rates. And when you invest money, it's going to say, do you want to do a risky plan? Do you want to go for this 8%? Or do you want to go for this like 3.5% that's guaranteed? So you go for different things. So, and when you get your little statement, it will say that. It will say, based on how you're investing right now, if you continue investing this way for 40 years, you're expected to have this much money. So it's nice. It tells you like how much you should be expected to have. So he has an aggressive plan, and he is making a whopping 9.2% annual interest quarterly. So how much will he be projected to have after 25 years? So I highly recommend that you write down a lot of things. So F of V is what we call the future value of your annuity. That's how much you want at the very end of your retirement, okay? R is your number, or is your amount you're putting in each month or quarter or whatever. So in this case, at the end of each quarter, he's putting in $700. So it's your periodic payments. All right, I, we said is R over N. It's our rate, which was 9.2, so 0.092 divided by 4 times a year. So we find that. So 0.023. And then N is N times T. We're finding the number of times he's compounding each year, which is 4 times per year, and the number of years he's compounding, 25 years, $100, right? So we find the future value of this annuity, FV. So we have 700. We're going to have 1 plus 0.023 raised to the n, which is 100, minus 1 all over 0.023, like that. So be careful on how you put it in. Anybody get his future value of his annuity? Okay, so $265,321.26. Is it enough? No, he only worked 25 years. So if he started at 22, most likely, he's only 47 years old. He's not ready to retire as much as he likes to. If he wants to retire at 47, well, you just got to put in more. You can't put in $700 every quarter. Every quarter, every 3 months, you're putting in $700. You can put in more, right? All right. So next one. So that's how you do like annuities. That's how you find how much you have at the end. So investments, how much you have at the end of a certain amount of time. But there's another thing that happens all of the time, and this is sadly going to happen before you start getting tons of money in your retirement account. You're going to have a loan. It's going to happen. You're going to have a loan on a car. You're going to have a loan on a house. You're going to have a loan on college. It's going to happen. So you're going to need to figure out how much you need to pay per month for a certain amount of loan, right? All right, and colleges actually legally need to tell you this now. They need to say, at the end of your 4 years, this is how much you owe per month for the next 15 years or whatever. Okay, and it's very daunting when you see it. It's like, oh my God, I'm going to owe like $600 a month for college for the next 15 years, right? It's scary. And there's a lot of people, a lot of my friends who are still paying off college. I'm 30, almost 33 years old. You know, some of my friends are still paying off college, right? We need to think about these numbers. Okay, so suppose you don't have an investment, but instead you need to make payments on something that you are purchasing now, like a house or a car. This would not use the same formula. Instead, it's going to use something called the present value formula. Okay, this is what the bank uses to determine what your payment should be. So if you're buying a car and the car is $30,000, do you think the bank's going to just let you pay off that $30,000 over the next 10 years and just call it even once you pay off the total of $30,000? No, you're going to have to pay way more than $30,000. Do you get that? Yeah, they want to make money off this deal. All right, so here's the problem. It says Audrey purchases a beautiful BMW for her 17th birthday. She tells her parents that she will pay for the car by selling cupcakes for the next 10 years. This, by the way, is terrible. Don't ever get like a 10-year car loan. We have like a little faculty a faculty thing for Mike Hagan's, his finance class, so a little faculty panel. And I remember Christine Linder. Do you guys know Christine Linder? She was pre-Taylor Newell. She was here, and they were like, what's the worst investment decision you've ever made in your life? And she said, I got a 10-year car loan. Why is that a bad idea? What happens after 10 years to your car? The car is not good. So sometimes your car doesn't last 10 years, and you're paying off a car that you now no longer have, right? So a 10-year car loan is not good. Usually people will do a 5-year loan or a 3-year. All right, so she decides that she's going to basically get a loan, and her parents are going to get a loan from the bank, but she's going to pay off her parents for this loan. So the car costs $32,500. So what are the monthly payments if she puts down $2,500? So she's putting down some money. She has some money saved from her cupcake making business, which she gives out for free to everyone. But she has $32,500. How much is the cost for a loan, though? Like, is she getting $32,500 put on the loan? No. So the first thing you need to do is you need to subtract out the down payment. So she had $32,500 was the cost of the car, but she already paid for part of it. She paid for $2,500. So how much is she taking out her loan for? $30,000, exactly. That is going to be your PV. That's the present value of the loan. Shh, girls. All right, again, let's write down the different things we have. So we have the present value of the loan. R is what we're trying to find. That's the number, or that's the amount of each payment. So every single month she's making a payment. We need to find out how much that is. I is R over N. So the rate is 3.1%, so 0.031. She's paying every single month. It's not a very nice number, so we'll probably want to store it. So it has a 3 repeating. So let's store it as A. All right, you could put the fraction in your equation too, but it gets pretty messy. All right, and then N is going to be N times T. So the number of times that she's paying each month is 12 times, or each year is 12 times a year, and the number of years is 10 years, so 120 payments. So we set it up, and we have $30,000 equals R, which is what we're trying to find, times 1 minus I, which we've now stored as A, so I'll circle it, meaning it's a stored value, to the negative 120. Oh, yes, it is. Darn. All right, Michaela got me. All right, over, see, I don't even have these formulas memorized because I think they're so crazy. All right, all over whatever that stored value is, A. All right, so do things one thing at a time. Make sure you're putting it into your calculator correctly. I forgot to store that A after I told you guys to do it, too. All right, so I have $30,000 is equal to R times 103.0683. Did you guys get that number? Mm-hmm. All right, so now divide 30,000 by that answer. What did you guys get for her payments? Yeah, $291.07. So that's not terrible. It's pretty good, but what's the downfall of this loan? It's 10 years, so her car could die after, 8 years, and she's still paying $291 a month for a car that she no longer has, right? You don't want to do that. All right, a lot of times, car dealerships will, pay for the rest of the loan if that happens, but you don't get money back from the car. All right, oh, that is the last one, isn't it? Okay, so do you guys understand those two different formulas? So future value is used for investments, okay? You want to find how much you have for the future. All right, a present value is saying right now, at this present time, you owe us money. How much do you owe us per month or per quarter or whatever? Okay, do you understand the difference between those two? I'll give you guys both equations, and I'll tell you the I equals R over N and the capital N equals N times T for both of them. Because I know those are tricky to memorize all of that.